G'day, it's John here from Das Slot Car Box. Well, today you're going to learn how to install the racecoordinator race management system software onto a Windows PC and connect and configure the Das Slot Car Box timing system in racecoordinator so that you can time lapse and also control the power to each lane of your slot car track. There's a lot to cover, so let's dive in. Let's talk about some prerequisites for racecoordinator. The system itself doesn't require many resources or a high-powered computer to run. In fact, we've had racecoordinator running fine on Windows XP machines. However, given that the current operating system is Windows 11 and the types of PCs that you need to run Windows 11, we typically recommend 10 or 11. And also that stays in line with the latest Arduino IDE software drivers that you'll see throughout this video. To give you some examples of mini computers that we are using, I'll just bring up the particular model that I'm using on my personal track, and then a few of us that own tracks in Melbourne are using as their track PCs. This here is a very modest spec mini PC. It is running Windows 11 Home S Edition. Now, I didn't mention that as a prerequisite, but S stands for security mode. What Microsoft does, S Edition pretty much locks down a computer so that you can only install applications that are available through the Microsoft Store. It's much the same as Apple and App Store. So it locks you down. So if you do look at and buy a PC with Windows 11 Home S mode, it's very straightforward to disable that, to allow you to install software like the Arduino software and also racecoordinator, which I will step through. But I won't go through the process of unlocking a PC from security mode. That's been covered, but I'll find a video and leave a link to that in the description if that helps anybody watching this. Well, the PC I'm using today, and a big shout out to my friend David Scott, who specifically bought this computer for me to record this video. I will buy it off him. It's a beauty. The reason I had to use this computer is that it has enough horsepower to do screen recording and install and run the software that I'm about to show you in this video. The previous mini PC I showed you, I did attempt that on my own track computer, so I wiped it, attempted the install, but it just didn't have the herbs to also process the process-heavy screen recording that I needed to record the video. The first step of this process is to download and install the Arduino IDE software, and the reason why we need to do this is so that the computer can then have the drivers installed to allow it to detect and recognize the Arduino Uno board that's installed inside the DAS timing system and communicate effectively. But the Arduino software is an integrated development environment as well. What that means is that it allows you to write code and then upload that code to an Arduino board. In this case, racecoordinator comes with its own what they call sketch program. It's a file that you can load into the Arduino IDE and send it or upload it to the Arduino Uno inside the DAS timing system, and that will allow racecoordinator to communicate with the Arduino for timing, etc., etc. So we will go through and do that now. The first thing we'll do, jump onto the Arduino website. I'll include a link to this in the description, but you can see here the Arduino IDE version 2.3.6 is the latest at the time of this recording. Also, you'll see that it's detected the version of Windows running on this computer as Windows 10 or newer. I can simply hit download. I'll do that in a second, but just wanted to bring your attention to the screen on the left here, or this image on the left, where you can see that the Arduino IDE, again, integrated development environment, allows you to write lines of code. You can see here, void setup, etc., etc. You do need this software to upload and send the version of the racecoordinator sketch to the timing system, and also when new versions are released, you'll also need to send those to the DAS timing system. But what I do when I send the timing systems out, I already preload or upload the latest version of the racecoordinator sketch to the boxes, so when you receive it, you don't need to do anything. You just need to install the software that I'm about to show you on the PC here, plug the box in, and away you can go. Let's go ahead and download the software. Okay, it's downloaded, so we can open the file. What I will do here, and I will speed up sections of this process where appropriate, but I wanted to go through and make sure that you see each and every step of the Arduino software install. The reason I use this brand new computer is that this has never been installed before, and it will go through a fairly lengthy process of installing drivers and so forth. So I've installed this software many times, and I implicitly trust the Arduino software and the program suite. But naturally, you as your own user, you'll need to read and review and I guess agree where appropriate. But I will simply skip through the options that I choose, and you can follow along if you choose to. Okay, install. This is the default install, so I'm just accepting the defaults that are presented, and then we sit back and wait. It does vary depending on the computer processing power and so forth. I'm just going to choose finish, and we can run the software straight away. What the Arduino software typically does when it first opens, it will check the versions of the programming libraries that it loads and uses, and it will update any that it sees fit. Now these are basically security settings that are prompted because of the install of the Arduino software, and you can see down here it's saying downloading packages. So it's busy in the background doing and making itself most up to date as possible. But again, because I trust this software and what I've done previously, I'm just going to choose allow. Okay, again, publisher Arduino, allow. Okay, there's a little, that caught me off guard there. It's a little dialogue there that popped up in the background, which I didn't see. So I need to allow that as well. Okay, and these next few screens you'll see, or messages that pop up, are to do with the COM port drivers. I mentioned before about being able to connect the timing system Arduino into the PC. So I'll just accept the default and install. Okay, again, Arduino USB driver, install. Another Arduino version of the Arduino USB driver, again, install. And this is a Uno USB driver. It's basically a clone version of Arduino, so it's a slightly different driver. Install that as well, and again I say yes, and you can see again things are happening down here. With the Arduino IDE program still open, what we're going to do next is plug in the DAS timing system's USB cable into the computer. And what that will allow us to do is to identify the communications or COM port that we will need to use and choose once we install racecoordinator and go into its configuration screen. So I'll reach over and plug in the USB cable into the front of the PC. Should have been a slight beep if you had heard that. What we can do now is, you can see in the bottom right here, no board selected, so we need to go and look for the board in the Arduino IDE, and that we do that under the Tools option here at the top. So Tools, and we go Board. So we want to go to AVR Boards, and we know it's an Arduino Uno, so we'll select that. And you can see down the bottom right it said Arduino Uno, but it still doesn't think it's connected. And also up here it says Arduino Uno. Now I need to go back into that Tools menu and choose the port. And you can see here when this expands, it says list of serial ports, and it's found the Arduino on COM port number 3. So that's what we choose. That's all we need to do at this stage. You can see here, it says down the bottom, Arduino Uno on COM3, and that's what information we will use after we've installed Race Coordinator and go into the configuration screens. The next step is to download and install the Race Coordinator software, which is a fairly quick process. But why do we need it? Race Coordinator is the brains behind the operation. Without that software, you can't do anything. The dust timing system augments and extends the Race Coordinator software to provide it feedback from the track through sensors and switch and relays. Let's jump on the web browser. I've favorited this link, but I will again include a link in the description. So at time of recording, the latest official release is version 1.15.3.0, and I mentioned the Race Coordinator sketch file. The current version that is supplied with this version of Race Coordinator is 1.0.0.14, preloaded on the timing system. So you shouldn't need to do that at all. But what we'll do here, I'll just click on the link and download it. It's quite, for what it is, it's an unbelievably small piece of software. Now you can see here, because I'm using Microsoft Edge, the default browser in Windows, supplied with a Windows PC, it said the Race Coordinator isn't commonly downloaded, make sure you trust. Yeah. So I've just clicked on the three dots here and said I want to keep the file. And again, I want to keep it anyway. I probably should have chosen report that it's safe, so that feedback goes back to Microsoft, but I might do that at a later stage. Okay, so it's almost done. There we go. It's downloaded, and we can go ahead and open the file. We can accept yes there, and we can go through the install process. Agree to the terms. Again, it's very generic, but please read through that, and if you agree, click I agree. Accept the defaults. I never change this, and I wouldn't recommend changing the default folder. Install. Yeah, and this is, for what it is, it's a very small program. It's unbelievable. There you go. So we've still got the timing system plugged into the computer, and what we can do next is run Race Coordinator and jump into the setup and configuration side of things. So you can see here it's checked to run Race Coordinator 1.15.3.0, so when I click finish it will run it automatically. If you choose to, there is a README file which describes all the changes that have been made to the Race Coordinator software to produce this version. It's worthwhile reading through that so you understand if there have been any fixes or more often than not improvements to the system, because the team's always improving and tweaking the system. It's again unbelievable. But I'll just uncheck show README for the purpose of this video, and I'll click finish. Race Coordinator is starting. This is known as the Race Coordinator race day setup screen. That is everything you need to choose the drivers, cars, the race and event type, before actually starting a race or a practice session. But what we'll do here, and in fact because this loaded straight after we hit the finish button on the install process, what I'll do here first is just close this screen, or close Race Coordinator down. And what I wanted to do is make sure that I showed you that the install process created an icon, a shortcut on the Windows desktop for Race Coordinator. So we can double click that to start Race Coordinator. And it does have a tip of the day. It's actually very useful to fully explore the Race Coordinator software. I'm going to turn that off so it doesn't show at startup, and close that. A very quick rundown of the Race Coordinator main user interface. Across the top here is the menu bar, so file. Some really important, two important things here. One is the database folder, so all the configuration settings we make get written to a database. So Race Coordinator stores that. That's a very important file. These two options, or this particular option, makes it very easy to find that file if you need to back up or restore a Race Coordinator install. So that's a very good one to know. By clicking on that, it just opens your file explorer to the location. You can see there's an RC. In fact, the file extension is not visible here, but if I just go to view, file name extensions, you can see it's an rc.db, so that's the database file. So I'll just close that. That second option is the show install directory folder. This is where the core program of Race Coordinator is installed. You can see across the top here, this PC, Windows C drive, program files, Race Coordinator folder. And you can see there's the racecoordinator.exe. So when we double click the shortcut on the desktop, this is the program that it runs, or the application you can see here. But the data folder is where it's all at in terms of a lot of the configuration files for Race Coordinator. And you can see the Arduino subfolder here. I'll just drill into that. So the lap counter.ino file is the sketch file that I referred to in the Arduino part of the video. So that is bundled with the Race Coordinator install. So if you ever need to find or locate that file, or to then be able to upload it to the DAS timing system, you can do so by choosing that Race Coordinator install folder and navigate to Data, Arduino, and into Lab Counter. You can double click this file, and here it's already, the extension .ino is already associated with the Arduino. You can see the Arduino icon here. So we'll open that code in the Arduino IDE, and you can upload that to the timing system as long as it's plugged in, of course. So very, very handy. I'll just jump back up a few levels. So back to the data folder, all the Race Coordinator audio files, images, things like avatars. In terms of these, you can see here for the drivers. So they're the avatars. You've got car image files as well. So they're the car files here. Our groups typically don't use this feature at all. Tracks as well, and also some user interface graphics as well for things like the traffic lights and so forth, the start sequence lighting and the like. You also have things like XAML. All of the race files, or the race day files, can be configured and use the XAML format. Very, very powerful, but you do need some know-how to be able to tweak those. And I believe some clever chap is developing an XAML editor for Race Coordinator. If I can find that link, I will share it in the description. But that's been posted on GitHub recently. But what we'll do, we'll just go across the very top of the screen quickly. Car setup, again, you can choose to add different classes of vehicles, or even create a complete car database if you choose to. Too much effort for our group, because a lot of cars, a lot of different classes as well. Driver setup, so basically creating and adding people that race with you on your particular track. So you can go in and add drivers there. I won't go into detail. There are wizard-based setups for most of these important options across the top here. I'd definitely recommend exploring those at your leisure, because they have very extensive descriptions and help explaining every option. And that's particularly the case under race setup, which has many, many options. And you'll see if you run through the basic, intermediate, and expert guided setup there. So track setup, that's where we set up the track interfaces that talk to Race Coordinator. So we'll focus on this, but I'll come back to that shortly. Race setup, I mentioned. You can see here, race and event selections. So that's where you create additional races, whether it's timed, laps, different durations for enduros, etc., etc. You can set up what's known as events. So a group of races to run at a given evening or an event. Seasons can be set up as well if you're running a points-based system across events and races. We don't use that. In fact, our group uses this software in a very basic way to keep things very simple. And options is basically the advanced preferences, if you like. There's some advanced features within Race Coordinator I won't go into here. About, I'll just click on that. There's some very worthwhile causes that you can donate to should you choose to. It's completely at your discretion. Dave and the team who write this software, they support and maintain it completely free of charge. They will never charge for it. Dave's committed to that. I've donated several times over the years, and if you continue to use this free software, because it is offered free, there are no trial periods associated with it, I would strongly recommend to support the development team. Let's now focus on the track setup. menu and configure the DAS system. Okay, the track manager, this is known as the track manager screen. You can see up here on the top left, 2 tabs, general and lanes. Let's just go through this screen very quickly. The track name itself, Bright Plume Raceway in this case. You can see on the right hand side here the actual track details. It's reflecting the name that's currently in the track name field, so Bright Plume Raceway. We'll see in a second when we jump across to the lanes tab that the number of lanes already configured for this track is 4. So there's 4 lanes there, but you can add and remove lanes as well. The number of track sections, we typically leave that at 100, but some large commercial tracks have their tracks divided up into sections or sectors. Track scale, this is defaulted to HO scale, 1 to 64, but we typically run 32 scale and 24 scale, so I typically set that to 32. Before we dive into the track interface part of the track manager and set up the Arduino interface and configure that, we must first set the number of lanes that the track has. So I'll just click on the lanes tab here, and you can see here the current lanes are set, and these are ordered: lane 1, lane 2, lane 3, lane 4 from top to bottom. And you can see here, to make a change to a lane, I need to first click on it in this current lane section, and it's in the right hand side here, it's telling me that the color of the lane, the actual font color or the text color, you can see here is the number 70. And also you can specify the length of your lane in feet, so in the imperial. So that helps with miles per hour or kilometers per hour calculations and some of the statistics you can get out of racecoordinator, which is pretty awesome. But so we typically work out lengths of our track and convert to feet and punch it in here, but I will just leave that for the sake of this video. You can add and update lane details. So for example, we've currently selected, it's hard to see here, but we've selected the tomato or the red lane, and there's 2 ways you can specify the color. You can double click, as you can see here, to access the color picker, or racecoordinator supports and recognizes some of the text descriptions of colors. So for example, if I typed green here and then came down and went update lane, you can see it's changed that lane background color to green, which is not a very nice green, in fact. And that's something that you need to keep in mind, is that you need to maintain contrast between the lane color, or wherever possible, maintain contrast between the lane color and the lane font color, because sometimes it can be quite difficult if the colors are quite similar to see, particularly if your track computer screen is a little bit distant from the driver's stations. The other way to set your lane color is you can double click, as it said before, and you can choose any color you like. You've got these basic colors, but if you want to define or describe a custom color, or if you know the red, green and blue codes, for example, you find a color on the web somewhere and you say, oh, I really like the look of that color, you can get the RGB or red, green, blue codes for that color and type them in here, and you can then add them to the custom color. So I'll actually do that here. Let's just change, let's find a greeny color. You can change the brightness here as well on the side. And you can say add to custom colors, and you can see now it's actually put it there. So I could say, well, I'd prefer that green rather than the khaki green. Click on that and go OK. And see, it's changed it to a specific hexadecimal code here. You don't really need to know what that is, but it's obviously a bit different to the word green. But to make that apply, again, you need to update the lane. So now you can see it's changed it to that color that we chose. As I mentioned before, clicking this update lane here only reflects the change that we've made here, but we haven't yet written it to or saved it in the racecoordinator database by updating the track here on the right. So if we need to save this information, we need to click update. And it's particularly the case when we start changing the number of lanes. For example, let me just select this last lane here, the yellow lane, and we'll go remove. And you can see here I've now only got 3 lanes described for this track, but you can see on the right hand side here it still says 4 lanes. So to actually make this change apply, I need to click the update button, and you can see now this is saved in the rc.db file I showed you earlier as a 3-lane track. And what this does do, the number of lanes also limits the number of options you select when we're in the track interface screens, and I'll point that out later. If you choose 3 lanes, you'll only be able to choose and assign up to 2 lap lane sensors, for example, or 2 relays. Because the track only has 2 lanes, it doesn't make sense to have 4 or 6 or 8 options to choose for a 2-lane track. So the authors of Race Coordinator thought of pretty much everything to make things quite easy and straightforward for us. But what I'll do here, I will go back here and add a lane, and what I'll do is very quickly go and assign the colors that align to the colors of the lanes with the timing system. So I'll quickly go and add a lane. What I'll do here first, the lane number 1 is brown. Yes, that's not very nice color, is it? Update lane, brown, that'll do. Select the next lane is lane 2. Just looking across at the timing system, it's blue. I don't like the default blue, but I do know Dodger blue is not a bad blue. Update lane, there you go. So now we've got 2 blues. So, but we're going to change lane 3 anyway. Lane 3, so I've just clicked on that here. It's Dodger blue, but in the timing system it is orange. So we'll just keep that consistent. Orange, update lane, and finally I'll click on the yellow lane here, and we're going to change that to the final color, which is green and green, and update the lane. And you can see there's the 4 colors there, and you can still see over here Race Coordinator still has only saved the 3 lane settings that we updated previously, but if I hit update now, that's changed to 4 lanes. So that's, you need to make sure that that is, you know, if you have a 2-lane track, it matches 2 lanes, etc., etc. So that's all we need to do here. Let's go back to the General tab, and this is the business end of the configuration. So the track interface is where it's at. So I will choose Arduino because the timing system is an Arduino-based interface. So we'll go for configure. Okay, there we go. Configure. All right, there are many tabs across the top here. I will only be concerned with the first 3. Just running through this, Race Coordinator can support multiple track interfaces. In fact, there are a couple of the track owners in Melbourne where I've configured 2 Arduinos, one to control the lighting, because they have extensive lighting on their track requiring more interfaces, and also a separate timing and relay control. So what I typically do here, just to make it very obvious, is I'd say I'll leave it as Arduino and type in timing and power, or relay. Relays, yeah, that'll do. And you can see here, the only option for us to choose is COM3. And it's actually come up with an error because we haven't selected anything yet. So I will just click on COM3, and I don't know if you heard that, but all the relay board activated. And the important thing to note here is that this connection light on this screen turned from red to green to indicate there is a connection, which is what we want. So we need to make sure that we select the COM port. And again, all the changes I make here, nothing applies until I hit accept. So you'll see me, after talking through a couple of these and making some changes, I'll hit accept, then we'll come back in, because I just like to do it in a staged manner, just so I don't forget to do anything. Now, the important thing on this screen, in particular with the Arduino, you can see here in the Arduino section, Arduino hardware, is defaulted to the Arduino Uno version of the board, which is what's installed in the DUS timing system. The important setting here is this debounce in microseconds. That U is actually representing microseconds. It's currently defaulting to 200. It's a period of time in which Race Coordinator ignores any repeat signals that are sent by lap sensors after a car passes over that sensor for the first time. We typically set this anywhere between 500 and 1000 microseconds. 1000 seems to work very well, and that's all I change here. What I'll do here is accept this, and then I'll come back into this screen and explain these other 2 tabs. So I'll just accept that. Again, I like to go update to make sure that in my head I've saved the configuration. But let's come back into Arduino and the configuration screen. And you can see here we're connected again. We're still selected on COM port 3. Now the other tabs here we'll go through. Analog. If you have some LEDs and start-finish lights attached to your track through an Arduino interface, you can actually configure them here. We don't need these configured for that particular interface, so what I'll do here, and it is good practice to set these all to unused. Otherwise, Race Coordinator is sending signals that it doesn't need to, and this just makes the configuration neat and tidy. So I'm just going into here and just setting all of these to unused. And again, what I'll do here, accept, update, and then I'll come back in and configure. It's just the way I do things. Next, we'll move across to the digital setup tab. This is where the rubber hits the road in terms of the dust timing system. So to configure the default settings, you can see here, the first 2 pins are unused, and then from pin 4 to 7 are the defaults. So we need to change those. So for example, the pin number 2 is lane lap sensor for lane number 1. Pin 3 is 2, 4 is 3, pin 5 is lap 4, and pin 6 and 7 are unused. Unused, and 7 are unused. Okay, and the relays are pre-configured in the dust timing system to these default pins, so pin 8, 9, 10 and 11. And the call button is also pre-wired in the dust timing system to pin number 12, and pin 13 is unused. Okay, what I'll do now, I'll just again accept this, update and configure. Again, you don't need to do that, it's just something I like to do. But what I wanted to show you in this screen, this is a hugely useful screen. This is a real-time interactive screen that will tell you how the race coordinator interface is working with the Arduino-based timing system. So for example, if I reach over and, for example, press the call button, look at the pin 12 call button over here. When I press the call button, it's actually responding and detecting that change in that pin. So that will then, Race Coordinator recognizes that as a call button press, so it'll start a race, it will put a race into yellow flag caution, and it will also help restart a race as well through the use of that button. And similarly with the lap sensors, for example, if I grab the lap sensor for lap number 1, lane number 1 here, and you can see that in the inset there, it's currently not it's receiving light because I've got a very bright light above my workbench here, and you can see if I cover it over with my hand, it's actually detecting that there's been a change in the signal. And if I uncover it, I cover, I uncover, I uncover. This is the way I test and QA the timing systems before they are sent to anybody, to make sure that every one of the sensors are working, the relays are switching. And so, for example, I'll go to the blue lane now, which is lap L2. Same thing again. I will point the top of the LED at my overhead down light, and so it's receiving light. I'm blocking the light now, and you can see it's actually changing. So my hand passing between the light source and this sensor is the same thing as occurs when a car drives across the slot of a track over this sensor. So same thing, I'll go for lane 3, orange, same thing, and lane 4 in this case. There you go, so they're all working. Relays are a bit harder. What I do as a bench test for these as well, I will click on these relays and make sure I hear a distinctive click out of the dust box. In fact, when I test these, I put my multimeter across the relay outputs to make sure that the circuit is open and closed with each click of these. I don't know if you can hear that in the video. So I test this for each. So that now I'm 100% confident that that timing system is working and configured for the DAS timing system. So I'll accept this, Again, I'll update just because I'm paranoid. I'll just jump back in here and quickly touch on the last few screens within the Arduino setup. So we've talked about the general, analog, digital. These last 5 tabs are for setting up programmable LEDs, so NeoPixels and the like. Look out for that in a subsequent video. I will be getting into track lighting. But I will cover this in a lot more detail in a different video. But you can have up to 4 strings of 24 LEDs for gantry lighting, countdown lighting, track side lighting for yellow flag. So the guys that I've worked with over the last 5 or 10 years and implemented this the hard way with third-party LEDs and hacking the racecoordinator Arduino sketch. It's all now built into the system to make life super easy, and I look forward to demonstrating that in the future. But what I'll do here now is just accept that update, and we can close that off. That concludes the configuration of the DUS timing system, configuring racecoordinator to access and use and communicate with that timing system. The next step now would be to install the timing system, install the light gantry above the sensors so that you could replicate the example of me breaking that light beam between the light source and the sensor to trigger and count laps on the track. Also, your power would be routed through the relay connections on the DUS box, and look out for another video on track wiring coming out very soon. The next thing we need to do is change the system power settings to make sure that this screen doesn't turn off after a certain period of time during a race without any interaction between the mouse or the keyboard. Let's do that by going to Windows, Start, Settings, and we can choose Power. And I'll just go up here and click System and Power. And the settings we need to look at here are screen sleep and hibernate timeouts. So we can just click on that option there and turn my screen off after. You can see here defaults to 30 minutes, so it would actually turn the screen off. So we set that to, we can scroll that down to never. And to make sure that the device, make my device sleep after never, that's all changed to never. And so that way the computer won't turn the screen off, blank the screen, or actually power down due to inactivity on the keyboard or the mouse. So that's all we need to do there. The first optional step I mentioned earlier is to set racecoordinator to start automatically after you first log into your computer. If it's a track computer, it just saves you an extra step. And to do that, we need to copy the racecoordinator shortcut you can see here on the desktop into the startup folder on this computer, so that when you first log in, Windows will look at what's in the startup folder and go, oh, there's a racecoordinator shortcut, and run that program without any interaction from yourself after you've logged into the computer. So to do that, we hit the Windows and R key together to bring up the run menu, and we type in shell : startup and hit enter, and it brings up the Windows Explorer view of the startup folder. You can see here, I'll just show you the Microsoft Windows Start Menu Program Startup folder. What we want to do is copy the racecoordinator shortcut into this folder. If you drag and drop it, it will move that shortcut, but what we can do here is press the right click button and copy that shortcut, and we can then right click in the window and hit paste, and it's dropped a copy of the racecoordinator shortcut there, so that will run automatically. And that's all you need to do. You can close this window. Next time you power down the computer, when you come back and power it on, log in, you can walk away and it will automatically start racecoordinator for you. The last, and I think essential step to setting up a Windows PC in general, is to uninstall any unneeded software and disable unnecessary settings in the system. A Windows computer comes pre-configured with a lot of software that most people do not need. For example, we're using this PC as a track computer, so we don't need things like Xbox Live, or we don't need Clipchamp or Microsoft OneDrive. Microsoft Teams and a raft of other software. So what we'll do now, I'll just show you how to navigate to where the list of installed apps are on a Windows 11 computer, and then we'll uninstall a few as an example, and you can do that on your own computer should you choose to. So let's go to the Start menu, we'll go to Settings, and then we can come up to this setting option up here, and click on that, and we scroll down to the Apps option, and we select the installed apps, and see the subheading here says uninstall and manage apps on your PC. So we click on that, and what it will do, we'll list 45 apps found on this computer. So I'll just make this a little bit longer so you can see the list a little better. But you can see here the first one, it's in alphabetical order, the Arduino IDE. That's essential, so we need that. There's a few things, for example, like Copilot, we do not need on the computer. So we can go in here and click on the three dots, uninstall, uninstall. Things like Game Assist, uninstall, uninstall. Okay, if I keep scrolling this down, Microsoft Bing Search, Microsoft Clipchamp, which is basically Microsoft's video editing software. So if we're not doing that on this computer, uninstall. Again, there's these things that can run parts of the software in the background and take up valuable computer resources. So Microsoft Teams, again, uninstall. And you can continue to go through here. For example, there's news. I'm not interested on a track computer. It's a single purpose machine. And you can go through things and remove OneDrive, etc., etc. So I won't go through and delete or remove all of them, but you can see there's several, there's Microsoft games here, and a number of weather, a few other things. Xbox I mentioned before down here. Get rid of that. Okay. Xbox Live, no thanks. And after removing or uninstalling apps like this, I would recommend doing a restart of the computer as well, because Microsoft preloads some of these applications in the background by restarting your machine. The ones that you've uninstalled won't be reloaded, of course.